too. So, like I said earlier, the molarity is equal to the amount of your solute, and you're doing it in units of moles, divided by your volume of the solution, which is in liters. So the example is, what is the molarity of a solution containing 25.5 grams of KBr? So what that means is your mass given is actually in 25.5 grams. What that means is we want to convert it to moles. So it's in enough water to make 1.75 liters of the solution. So your volume is 1.75 liters, so we don't need to convert anything for that one. So starting from there, the molar mass of KBr is, looking at our periodic table, KBr added together is 39.1 plus 79.9. So it's 119 grams per mole. So you start with 25.5 grams of KBr times 119 grams in 1 mole. And since we have moles on top already, like over here, we can just divide it. So it's 1 over 1.75 liters. How can I do 1? It's almost like if you think of it as, if you're given a volume, it's 1.75 over 1, it's still 1.75. So if I flip it, I can do the same here. So doing it like this, what do you get?
So do you have to divide 25.5 by 119?
So with these, you want to make sure that you're multiplying everything on top first and then dividing by the total of the bottom. So you'd set up in your calculator as 25.5 divided by 119 times 1.75. You want to make sure anything in the numerator and like the denominator, you're going to multiply each of them by themselves first. Whatever is on the bottom, everything's multiplied together. Everything on top is multiplied together, and then you divide. If you don't, then your numbers can really go off from there.
Okay.
Yeah,
I
so
got
then, what did you get?
I got 0.1224. I don't know how many
One, two,
oh wait, oh
two, four.
sig fig. So I think 1.22.
Okay, yeah, so it's 0.122 molarity. That'd be your answer. Yep, that's right. Okay,
And could I ask a quick
so
question?
yeah.
That's
Mm-hmm.
okay. Could you explain the difference between molarity and moles,
So
if that's okay?
yeah, so molarity, it's given for a solution. It's almost like, so what chemistry class are you in right now?
Chem 22?
22. Okay,
Yeah.
so hopefully by the time you take Gen Chem, you're going to be able to go into the lab. So usually you're given a solution. So solutions are typically given a molarity. So molarity of a solution means that I put in this case, you used KBr, right? So we put in 25, we put in actually 25.5 divided by 119. We added 0.214 moles of KBr into water. So water was 1.75 liters to make a solution of moles over liters, and molarity is just the name, is just the unit for moles over liters.
Oh, okay.
Yeah, so moles is a different unit when, like in this case, it's the unit in which we're measuring the mass of KBr. So molarity is the unit for the solution of of KBr in water or any of the compound dissolved in water.
Oh, okay.
Mm-hmm.
That makes sense.
Yeah. Okay, so let's do a practice problem. So I'll give you a few minutes to do this. Let's give you till 7:16. So I want you to find the volume in ml. So you have to convert to make what's given already, the molarity of 1.50. Remember, molarity is the unit of moles over liters. And this is the mass. Okay, so let's do this. How about you guys tell me what you guys got for your molarity?
I got zero
What
point
volume? Yeah.
point 252.
Equals to
I don't know if mine's right.
252 milliliters. Yep, that's right. Did you guys all get that? I can write the process out. So how about you guys walk? You started with 45.0 grams of KBr, right?
Yes.
Yeah, you guys can talk too. Don't worry about it. So then you use the molar mass of KBr to get 1 mole. When you're looking at this, they gave you the molarity. So, yeah.
Or I have a question. How we can get that number 119?
So you have to add it's the molar mass. You have to add the mass of potassium and the mass of bromine together from the periodic table. So potassium is 39.10 and bromine is 79.90 grams per mole.
Oh, okay.
So then you get 119.
39.
Yeah. So you have this setup, and then you have 1 liter over 1.50 moles. And since I'm asking for the volume in milliliters, you also have to convert.
Mm-hmm.
Okay, this is lagging with the sharing. Okay, so then it's 1,000 milliliters in 1 liter. So you'll notice that the units are canceling out. And your final answer should be 252 milliliters. And that's your volume. And yeah, so this is how you got it, how you get it. That makes sense. You can also, if you wanted to, so since this is M equals to moles over liters, you know, in order to get your liters, you have to rearrange it where it's liters equals to moles divided by molarity. And it does work out that way. It's just the unit cancellation.
Okay, so
Yeah.
1 to 1.5.
Do you guys have any questions on this problem? We can move on to the next one. We have, I think, about 5.
So
5 more problems. Yeah.
yeah, we can go to the next.
Okay. Okay. So
Thank you.
this one, I'll give you guys to 7:26 to do. I want you to tell me the mass in grams of N sodium nitrate that you need to make 1.1 molarity of NaNO3 solution. This is volume. Okay.
Wait, so the big M is moles?
Big, like this. So big M is molarity.
Oh, a molarity.
Little m is mole, or mole can also be denoted as N. I think you guys might be used to seeing it as N
Yeah.
in a formula. Yeah. So N would be, it's just N over L, N over V.
Oh, okay.
Yeah. But usually when people write it, they write the units just because your units cancel out whenever you're using molarity, and you're left with whatever unit you want left over.
Oh, okay. Okay, thank you.
Mm-hmm. Okay, so let's look at this problem. Okay, I just want to make sure my writing is up. So when you're looking at it, you're already given the volume, but it's in liters, in milliliters. So you need to go from milliliters to liters. And you're given the molarity already. So let's convert first. So 400.0 milliliters. You can, actually, let me do this first. So moles, the units is moles over liters, right? So molarity is equal to mole over liter. We are trying to find mole right now. So if you rewrite this problem, it'll be where mole equals to molarity times liters, right? So you want everything to be multiplying on the top, basically. That means is you can start with 400.0 milliliters, just the unit conversion of 1000 ml to 1 liter. So from here, where do you think we go? So let's use the molarity since we have the volume already now in liters. Would 1.1 go on top or bottom?
On top.
Yeah. So 1.1 is moles in 1 liter. And then since you have that, now you need 1 mole of NaNO3.
Where's,
What's,
sorry.
yeah?
Oh, never mind.
Oh, okay.
Sorry.
So the molar mass of NaNO3 is 85 grams. So now you can just do the math. Let's do it in your calculator and tell me if you guys get the same answer as me.
Oh, I got 37.4.
Yep, 37.4. We have
Grams?
moles.
Oh, moles, my bad.
Oh yeah, grams, sorry. Yeah, grams of NaNO3. We actually want 2 sig figs. So how would you do 2 sig figs for this?
You would round it to 38 grams?
So no, so you would actually do
Oh,
3.7.
shoot, sorry, 37. Sorry, my bad.
You
You
can do,
round it if it's over 5.
yeah, so you can leave it as 37, or you can do 3.7 times 10 to the 1 grams.
Oh, it's to the grams.
Yeah, it's the same thing. Yep, and that's it for this problem. Were you maybe confused at the part where it was getting it to NaO, the mass of NaNO3, sodium nitrate?
I just had trouble setting up the problem.
Oh,
The way you
okay.
did.
Did this clear it up?
Yes, it did. Thank
Yeah?
you.
Okay. Let's do the next one. So the next one is, what is the molarity of zinc chloride that forms when 25.0 grams of zinc, it completely reacts with copper chloride according to the following reaction. So this is balanced already, and you're going to use this to do your mole to mole ratio. So the final volume is 275 ml. You want to convert it to liters. I'm going to give you until 7:38. If you guys finish earlier, we can get to it. So you guys have that time to do this. You're going to calculate the molarity of zinc chloride, which is this one.
Okay.
And you guys see my screen? Okay. Yeah. So this is the work. So I wrote down what was given earlier. So we know, since we're calculating molarity, is moles over liters. As long as your units are like that, then you are fine. Did you guys all start with the mass of zinc?
No, I thought it was the mass of zinc and chlorine.
Okay, so wait, so here, my question is, did you get the same answer then, or no?
No, I got
No?
1.41.
Okay, so when you're looking at the question, they're asking what's the molarity of zinc chloride. Since they gave you zinc, you're supposed to start with zinc over here, and you're going to use this ratio of 1 to 1 that we get from the reaction to get zinc chloride.
So I did zinc chloride by accident. I did a
Mm-hmm.
Cl2 by accident instead of Cl.
Oh, okay, okay.
Yeah, so I had a different number. That was my mistake.
Okay, so we start
I
with
started
25. Yeah?
I started backwards. I started with 275 milliliters
Mm-hmm.
and then divided by 1,000.
So let's do 275 ml. And then you got 1 liter. And did you stop there or did you continue?
I then wrote 1 mole of ZnCl2 over 1 liter.
So let's see, 1 mole.
Yeah, then I got kind of lost.
So here's the thing with this. What happened here is your liter ends up on top. You don't want liters to be on top
Mm-hmm.
because the
Okay.
molarity, your liters is on the bottom. If you had instead done in where you stopped here and you found that 275 divided by 1000 is 0.275 liters, and you
Yeah.
save that to plug it into this formula.
All right. Yeah.
So if you had saved that, and then what you did is you do everything up to here, and you take that number that you get, and you divide it by this volume, you should get 1.39.
Okay.
It's
Yeah.
the difference, the difference in this, what you could have done versus mine is I did mine in one line like this versus breaking it into 2 parts and then plugging it into a formula. If
Yeah.
you're able to see that molarity has the units of moles over liters, if you do a step-by-step setup like this, as long as your units cancel out and you're left with your desired moles, then it's right. So you'll see that you're only left with moles of zinc chloride over 1 liter, over the unit of liters.
Yeah.
Yeah. Did they
Yeah.
clear it up for you guys?
Okay, so anytime it gives you, so you start off with the zinc because it's the given
Yeah, that
first.
you didn't have any other mass to go off of.
Okay.
Yeah. Are you guys good? We can go on to the next solution dilution. Again, you guys will get a recording of this, so that might help when you're reviewing it. Okay. Okay.
Okay.
So then, yeah. So the next thing we're going over is solution dilution. Oh, Aaron left. I think his interview dropped maybe. So dilution equation here is M1 times V1 equals to M2 times V2. So it's just your initial concentration times your initial volume is equal to your final volume and concentration. The practice problem for this, we'll do this together first, and then the next two will be on your own. So you have 3.5 liters, that's your volume. V1, your initial. This is M1, which is your molarity, and they give you your second volume. So they want you to find M2 equals to what? So if we go from M1 V1 equals to M2 V2, let's rearrange this, and then you can just plug in your numbers. As long as they're the correct units, you can plug these numbers in. So if you want M2 only, what you would rearrange it to would be M1 times V1 divided by V2. So let's plug it in. So 4.8 M times 3.5 liters divided by 45 liters. When you do the math, 4.8 times 3.5 divided by 45.
It's 0.37.
Yeah, 0.37. So you want two sig figs, and it'd be molarity. And you'll see that your units cancel out. Okay, I'll give you guys till 7:47, 3 minutes. You guys can do this. If you need a little bit more time, I'll give it to you. Okay, to do this one. We just started molarity, the solution dilution problem. So you can do the next one with us, on your own, but this one we'll be reviewing right now. So Brittany and you, are you guys ready? Can we go over?
Yeah.
Yeah? Okay.
Yes.
So for this one, let me resume share. Okay, so this is what I got. So the first thing I did was rearrange this equation right here, M1 times V1 equals to M2 times V2, where M2, which is what we want to solve for, is M1 times V1 divided by V2. So similar to the previous problem. First thing I noticed after that is your initial volume is in milliliters. So I convert it to liters, and then I just plug it into what we did the setup as. When you plug it in, your liters cancel out, you're left with molarity, and once you plug it in, you get 0.027. Did you guys all get the same?
Yes.
Yeah.
Okay, so we'll go on to the next problem. So problem 3, I'm going to give you guys until 7:51 to do it. 7:52, 53 to do it. Okay. Or actually, tell me how long you guys need. And remember, it's M1 V1, M2 V2. In this one, you are solving for volume instead. So rearrange it to how you guys think it is.
So teacher, I said we need to find a V2, correct?
Yeah, you want to find V2.
Thank you.
So for this one, first thing I did was I rearranged the M1 V1 to you want V2. So it's M1 V1 divided by M2. So with that, everything is in the correct units, so you don't have to do any converting. So you can just plug it in as is, where M1 times V1, which is 10 times 0.200 liters divided by 1, and you're left with 2.0 liters. You guys all get the same answer?
Yes.
Yeah? Okay. Any questions?
I see it.
Uh,
Thank you.
okay, Aaron, you broke a little. I think you said you don't have any.
I
Did you? You can type it if
was
you want.
unaware that
Yeah.
you have to do that like for I wasn't aware of that formula.
Oh, okay. Yeah. So that's why I wrote it earlier.
Oh, no. I got it now.
Okay, you got it? Okay. So now I'm going to give you guys these challenge problems. We're not going to do it together, but these are for you to try on your own. And you guys are all familiar with scheduling a tutoring appointment with a tutor? If
I
you
actually
guys,
don't know how to do that.
Yeah.
Yes.
Yeah? Okay, I can walk you guys through how to do it after this, okay? So how about you guys can screenshot it if you want, but I'm going to send you the recording too. It's up to you. It might be easier to screenshot right away. It takes like probably 20 minutes to load before I can send it to the NatSci Center to email it to you guys. So this is problem 1. Let me know when you guys are done taking a picture and I'll move on to the next ones.
Yeah, done.
Done? Okay. Next slide. Problem 2.
Can you go back to the last one? So I haven't taken a picture from the
Oh,
last
this one? Yeah.
Yes,
It's okay.
thank you.
Mhm.
Okay, good, thank you.
Problem 2.
Yes, we're good.
Okay, my hint for this one for you guys is you're working from 25.0 grams because they're telling you how much has been produced already. You want to be able to get to this. Okay. Problem 3. There's one more after this, and then those are the 4 challenge problems. So limiting reagent is what is the minimum. Well, actually, it's the maximum amount that can be made, really. What that, sorry, no. So limiting reagent is the maximum amount of reactant that you have. So for that one, this one, you're going to use this information and you're going to find, is it this reactant or this one? That is the limiting reagent. So which one runs out first? Because that determines how much you make, which is your theoretical yield. Which is your theoretical yield. And then using your theoretical yield and what is the calculation here, you'll be able to calculate the percent yield of this reaction, of the product.
Okay.
Which is this right here. So when you're finding a limiting reagent, you're actually converting all of these, this reactant and this reactant, to BaSO4.